There are three random variables x, y, and z. Correlation between x and y is 0.8 and correlation between x and z is 0.8. What's the maximum and minimum correlation between y and z? We know that the sample correlation matrix is always positive semi-definite. And there are a number of different conditions which tell us when exactly is a matrix positive semi-definite. Some of these conditions are listed here. A matrix is positive definite if it's symmetric and all of its eigenvalues are positive. If the quadratic form x transpose x is greater than equal to 0 for all vectors x. If the matrix can be written as R transpose R for some matrix R with independent columns. And if it's symmetric, all of its pivots are positive. But let's try to solve one of these conditions from scratch and see why exactly this holds true. Consider a data matrix R. X is an n by p matrix. We have n observations and p variables. So each of xi is an n by 1 vector. We normalize x by subtracting the mean and dividing by the standard deviations. So for each of xi, we take the mean, which is mu I, and the standard deviation sigma I, and we subtract the mean and divide by the standard deviation to get the new matrix W, which is the normalized form of the matrix X. Now that we have the normalized matrix W, we can find the correlation matrix as W transpose W divided by n minus 1. Now consider any p by 1 vector z. We calculate the quadratic form z transpose cz. And we can solve this to write it in terms of the matrix W as WZ transpose times WZ. Now W is n by p and Z is p by 1. So this would be 1 by n vector and this would be n by 1 vector. So this is an inner product of these two vectors which will give us the sum of squares, and sum of squares will always be greater than or equal to 0. So the quadratic form of matrix C is always greater than or equal to 0. So we know that this sample correlation matrix will always be positive semi-definite. So let's recap what we have done here and also add some important useful points. Given a matrix X with variables as columns and rows as data points, if we standardize columns of A, that is subtract the column mean and divide by standard deviation, then A transpose A divided by n minus 1 is the Pearson correlation matrix. If we center the columns of A, then A transpose A is the scatter matrix and A transpose A divided by n minus 1 is the covariance matrix. If we unit scale the columns of A, then A transpose A is the cosine similarity matrix. If we center and then unit scales of columns of A, then A transpose A is again the correlation matrix. So these are some useful pointers which can be helpful in a number of different problems. Now coming back to our problem, we are given that correlation between x and y is 0.8, correlation between x and z is 0.8, and we have to find what's the maximum correlation between y and z and minimum correlation between y and z. Let's assume the correlation between y and z is R. So the correlation matrix can be written like this. We have the correlation between x and y 0.8, x and z 0.8, and the correlation between y and z we have assumed R. Now we know that the correlation matrix is positive semi-definite, and one of the properties of a positive semi-definite matrix is that the determinant is greater than or equal to 0. So we'll use this property to find the range of R. Solving for the determinant of the matrix C, we get R minus 1 times R minus 0.28. This is greater than or equal to 0, and this gives us the range of the correlation R between 0.28 and 1. So this is the final answer to the problem.